Alright, we are looking at problem number 16 from the text, number 16. And we've got a cannon that weighs 225 kilograms that when fired rolls backwards off this tower, and we want to know where it lands. We do know that a cannonball of 4.5 kilograms was fired out of the cannon and landed 215 meters away from the tower. This step right now is actually quite involved. We need to start with V equals D divided by T. And we can do that little switching trick right here where we take these two variables and we just switch them. And our new formula becomes T equals distance divided by velocity. Now the reason we need that is because we only know distance in this problem. Velocity is part of momentum, and what we need to know is that time for both the cannonball to fall and the cannon is equal. So we can write it like this. The d of the cannonball, I'm going to do that as dB, over the velocity of the cannonball is equal to the d of the cannon, call that C, and the v of the cannon. Alright, then we can start to fill in a few variables. We know that the distance is 215. We know that we're solving for the distance of the cannon. We know that VB and VC are underneath those. So we can then rearrange this algebraically. If you take your time, you can rearrange this as x equals 215 times VC over VB. Now, that in and of itself doesn't really do us anything. We only get part of the information that way. Now, I'm going to have to jump to a new page and start now with the next step. We know that the cannon ball has a mass of 4.5 kilograms, and we'd multiply that times VB to get its momentum. We know that the cannon has a mass of 225 kgs times V of the cannon. Once again, pretty in-depth. You'd have to make some of these steps on your own. Now then we would rearrange all of this to say the V cannon over V ball is equal to 4.5 over 225. And here's where we should be able to start to see the commonality. If I go back the page, we see that we had VC and VB right here, and we can start to put the information together. Now we can rewrite this as x equals, substituting in 215. Before we had VC over VB, now we're going to write that as 4.5 over 225. And we've solved the problem. The final answer is 4.3 meters. The one thing we could do in this problem is add a negative showing that the cannon goes in the opposite direction. There is a second part, and it says, does the width of the tower matter? And the answer is no. In a Newtonian frictionless world, there is nothing to stop the cannon. So, Newtonian frictionless world, the width of the tower does not matter. The cannon just keeps rolling backwards. If you've ever watched an old Revolutionary War or Civil War movie, you know that you see the cannons roll backwards a few feet. There is friction in that case between the ground, the cannon wheels, and so on. But in this problem, no friction. Width does not matter.